Suppose that it is reported that 90% will vote for candidate A. You think this percentage is different in your neighborhood, so you decide to randomly sample 145 people and ask them if they will vote for candidate A. Is this sample size large enough for this distribution to be normal distribution of sample proportion? We have to check the condition n times p times 1 minus p. If it's greater than or equal to 10, then yes. If it is less than 10, then we're going to say no. So this is equal to n, which is 145, times p, the probability is 90%, so times 0.90, times 1 minus p, 1 minus 0.90, and the answer is definitely greater than 10, so the answer here should be yes. For the first part of the question, we're going to type yes. For the second part of the question, we will need to find the mean of the distribution of sample proportion. We know that the mean of the distribution of sample proportion is equal to the population proportion, which is 0.90 in this case. So this is yes, and this is 0.90 here. The standard deviation of the distribution of sample proportion follows the formula p times 1 minus p divided by n, which is equal to 0.90 times 0.1 minus 0.90 divided by 145. So I'm going to compute this answer right here. Square root of 0.90 times 1 minus 0.90 divided by 145. And this is the answer for the standard deviation. So I'm just going to go here and paste the standard deviation here. And then I'm going to paste the mean as well. Suppose we find out that from our sample, 137 will vote for candidate A. Give p hat. P hat is the sample proportion. The sample proportion is basically how many people will vote for candidate A, the proportion of people who will vote for candidate A out of the sample size. So the answer is going to be 137 divided by 145. So p hat is equal to 137 divided by 145, and this is called the sample proportion. So I'm going to compute that here. 137 divided by 145. That is the proportion. I'm just going to copy that and paste it into here. The last part, what is the probability that at least 137 people will vote for candidate A? Now, in this case, you notice that 137 is a number and 145 is too large to create a binomial distribution. We need to use the information we have because it meets the condition. It can create a normal distribution if we create the distribution of sample proportions with a mean of 90% and the standard deviation of this number. So we are going to create a distribution of sample, and in order to use that distribution, we need to turn this into a proportion. Lucky for us, we did that already in the previous step. We found the proportion for that number. Because 137 is a number, it doesn't fit with the proportions of the distribution of sample proportion. So here is the normal distribution of the distribution of sample proportion with a mean of 90%. The number 137 is too big to fit here. This is a number line basically that has proportions at the bottom. So this number has to be turned into a proportion first before we use it. And we already did. It's right here. So we're going to use this proportion, 0.94, approximately 0.5. It's approximately here, and we need to find the probability that at least, that means either these or more. So we want to find this area right here. This is 0.944828, which is the proportion of 137 divided by 145. So to compute the area to the right, we know that we're going to use 1 minus norm distribution of the proportion. I'm going to write the proportion here, 137 divided by 145, comma, the mean, comma, the standard deviation we computed, which is this number right here, comma, true. So I'm just going to compute that here, norm distribution of the proportion 137 divided by 145, comma, the mean 0.90, comma, the standard deviation. We computed that here, so I'm just going to click on it, comma, true. So that is the answer. I'm going to copy the answer and paste it over here. So this is how you answer this question. Hopefully this helped you, and I'll see you in a different video.